तो गुड इवनिंग गाइस। तो मेरा नाम सोमदीप माजी है। So today I am going to start with the petrophysical properties. We will be inclined towards the GATE syllabus and try to cover all the topics. So uh, we will be following Abhijeet Dandekar book for petrophysical properties. So without wasting any sort of time, we are going to the first chapter, or especially the second chapter, which is core analysis. So you can switch the video in 1.5 or 2 as per your need. So we will be studying the first chapter is core analysis, coring methods. We will see the rotary method, sidewall coring, high pressure coring. Let's see with the whole core plug. We'll see it, and we will discuss it in very brief, and you will be able to understand the concept very clearly. So coming to it, as you can see, I've highlighted some of the points. So basically, first we come to the coring methods. What is coring basically? What is coring? Coring is in coring. So here you can see that it's just a, a cylindrical sample of reservoir rocks, and it is corrected during drilling with the use of with different methods. So we will look up onto those methods later. So now coming to the methods which I've said, the three basic methods. Two of them are conventional methods, and one is an advanced technique. So now coming to the first two conventional methods, rotary method, so and sidewall coring. So first I will discuss rotary method. So what is rotary method? Rotary method is basically, you can see this uh, what I have drawn that time. It is basically a core. When how it is done. So first of all, this is a drill bit. There is a core catcher or core handler over here. So with this, using certain procedure from the uh, formation wall, we take a core. So you can see a core. It has a core barrel, a core catcher, uh, and it uses a coring bit. And there is certain method of that which is no need to know about that. But the core which we take is a whole core. As you can see, we are taking from a core holder. The core is sufficiently large. The core is sufficiently large. It's a large core. So if you want to see the diagram, and first I will show this. Now I will show sidewall coring also. Then I will show the diagram. So in sidewall coring, what happens? Sidewall coring, they are hollow cylindrical core barrels or bullets. Through this, we take uh, very small core plugs. So what is core plugs? We have seen this. This is a core. So core plugs are very small. So if I compare the size, it's just like it. It is very small. You can see this. So how a sidewall coring actually looks like. So just basically, if this is the downhole instrument, here you will see uh, hollow hollow cylinders. all right, with springs attached. And when we need to take the core from the surface, we, we give a signal, and this, just like bullets, it comes out. And there is the uh, formation wall. As it comes out, it it actually penetrates it, and takes the core, and then again returns back and brings the uh, uh, core plugs to the surface. So you can see a comparative size of whole core and core plugs. So this is the whole core. Total is it's a whole core, and these are the core plugs: vertical core plugs, horizontal core plugs. So basically, one thing we have to keep in mind, that in sidewall coring we get whole cores. Sorry, core plugs. But in a rotary method, we get whole core. All right. So now coming to the unconventional method, and it's very important. It is known as high pressure coring. Now, what actually happens is that in sidewall coring and rotary method, everything, these both methods, these are these are subject to loss of fluids as cores are brought to the surface. Means as we bring the core from the downhole environment to the surface, that pressure, temperature will change. As it changes, the the composition of the fluids, such as liquid, will change to gas. Some liquid will change to gas, and these things will go on, and there will be several changes in the composition. The composition of surface sample will not be equal to composition of the reservoir sample and reservoir conditions of the same sample. So this is a great problem. All right. So what high pressure coring uh, does it solves the problem. How it solves the problem? As the name suggests, high pressure coring. High pressure coring method attempts to circumvent this problem, and this method is relatively expensive, and this offers distinct advantages. The pressure barrel collects the, so you can see this pressure barrel. As we have seen there, core barrel and other things. There were written core barrel in whole core, and there was also core bullets and sidewall coring. Here we use pressure barrel. Remember this, which method uses which type of which instruments. What is the name of the instruments? Nothing difficult. So collects the reservoir fluids and then natural content, that is reservoir rock, by maintaining the core specimen at bottom hole or reservoir conditions. But it maintains the specimen at bottom hole and reservoir conditions. It maintains the pressure and temperature of the sample. And now what happens, that as these are constant, so everything is okay, everything is fine, no change in composition or any factor. So this is just basically a thing. And An additional requirement to this high pressure coring is the necessity of freezing the core in order to immobilize the hydrocarbon fluids within the core. Once these fluids are immobilized, the core can be removed from the barrel after depressurization and subsequently transported in frozen state for laboratory analysis. Means what happens? So, what a high pressure core does? So, it brings the core sample to the surface. Okay, we brought it to the surface. Now, from the surface, we need to take it to the laboratory. All right. So, in between, there will be a transportation. So, we cannot take the whole uh, barrel, right? So basically, we have to use or pressure barrel. So basically, in the pressure barrel, we also use freezer, which freezes the core fluids. Now, what happens if it freezes? Fluids become immobile. So as a result, will not come out. Now, after taking out from the barrel, we will keep it in a container freezer, and it will be additional requirement high pressure coring is necessary freezing in the core in order to immobilize, and as it immobilizes, and after that we will transport it to the lab, and in the lab there will be the experiments, and then the experiment is done and we have got the information. So here you can see it's written about the whole core, the same thing, basic complete section of conventional drilled core from information. The advantage of whole core analysis is that measures the properties of large scale somewhat closer to the reservoir. We can take the whole core just like the reservoir. Why? Because it's very large a size. It's very large size. And here you can see what he has written. These are only used as reason to believe that smaller samples or core plugs do not reflect average properties. That we use core plugs, so they are very small. So so they are very small part uh, of the core. They are very small part of the core. If you see the core in comparison, it is very small part. So we cannot determine average properties more accurately. So basically, actually, what we do is inside our coring or core plug, generally, uh, the plugs we take, generally, the core plugs cut from the whole core sample and different orientations, perpendicular, parallel, axis, whole core, that drilled from whole. So uh, actually, when we take sidewall cores, we also use well logs. Even we use with whole plug also, whole core also, but sidewall we must use as this gives us more accurate more accurate properties. So what properties we will talk to you about it later. So basically, this is the core. All right, this is the core. So what does a reservoir engineer look for? Reservoir engineer looks for these porosity, permeability, grain density, mechanical electrical properties, fluid saturation, wettability, capillary pressure, relative permeability. Geologist looks for lithology, petrography, deposition, petrophysics, log calibration, saturation, rock mechanics. Completion engineers, formation damage, completion design, and means different sectors of people look for different sorts of data, and they all get it from the core analysis. So it's very important, and this core analysis, when it is done, actually it's done a lot of times, but basically it's much more important during the appraisal and exploration and exploration phase of the planning. If you see PRMS, I have studied PRMS, or which I will cover in another lecture. You will know what is appraisal and exploration. And basically, exploration means the first stage of finding oil and gas, and this is very uncertain. Uncertain. In appraisal, we just we just determine the amount of oil and gas present. That is basically the volume of the reservoir, and the by drilling more number of appraisal wells and taking the core analysis, we also determine other things. So uh, we see various of the properties. So first, now we come to the types of core test. There are basically two types of core test: routine or conventional core analysis and special core analysis. It is also said as RCAL, uh, RCAL or RAL, RCL, RCA, sorry. So, and there's special core analysis, which is also said SCAL or special. uh, So these are denotations. Wherever you see this SC and RCA, you can understand this is conventional core analysis and routine special core analysis. So what happens in routine core analysis? Routine core analysis generally refers to the measurement of porosity, grain density, grain density, horizontal permeability, that is absolute permeability, and absolute horizontal permeability, fluid saturations, lithologic description of the core. So these are the things which you get from routine core analysis. From special core analysis, we get which some advanced things or very important things, such as you can see two-phase or three-phase fluid flow or displacement experiments, the formation rock sample, which are very very important. And some other informations also, we use various type of advanced techniques. We get the relative permeability, wettability, capillary pressure, and these three things are also determined over here. So basically, if you make a quick note, which is important thing, so what happens is routine core analysis. We basically get the porosity, grain density, we get horizontal permeability, absolute permeability, we get fluid saturations, SO, SW, SG, and lithology. This is taken from the routine core analysis. For special core analysis, we basically get the relative permeability, the wettability, the capillary pressure. So we will discuss about it, wettability, capillary pressure, in the upcoming lectures. What are these? Wettability and capillary pressure and relative permeability will come with this, and these later. So basically, these things are determined from the special core analysis, and basically the experiments include two-phase, three-phase fluid flow and displacement experiments in the formation rock sample, and that's why you can get the relative permeability and all those things from the two-phase and three-phase fluid flow or displacement experiments. So we use all these things over here. So I think, and nothing more is there. So next chapter will be porosity. We will discuss about it later. So if you have any doubts, let me know in the comment section. I will try to clarify them as much as possible. Thank you very much.